1800s, it was said that physics was mostly solved and that all that was left to do was to tidy up one or two things. And then this experiment came along and changed everything. Today, we are talking about the photoelectric effect. Now, this isn't one specific experiment, it is an experimental setup that revolutionised quantum mechanics, and that's why it's important and made it into this series. At its core, the photoelectric effect is very simple. You shine light at a metal, and that metal, then stimulated by the light, releases electrons. Now, there's two main properties of light that we need to talk about. That is amplitude, or intensity, and frequency. The amplitude, or intensity of a wave, is how big or small these bumps are, how high or low they move off the centre line. The frequency is how close these little bumps are together. High frequencies have bumps close together, low frequencies have bumps far away. The confusing result about photoelectric experiments seem to be that the intensity of the light and the duration of the light have no effect on the amount of electrons or the amount of current that is then produced by that metal. However, changing the frequency, not the intensity, did change the amount of electrons that were emitted by the metal. If you imagine light as a wave, this does not make any sense at all. Changing the frequency essentially just changes the colour that we perceive that light as, and it was thought that adding more and more waves would give more and more energy to the metal. However, this isn't the case. The breakthrough came from realising that light sometimes acted as little particles that we now call photons. These photons are essentially little packets of quantized energy that make up light. Higher frequency gives more energy to these little packets of light. Higher intensity means that there are more photons there in the first place. This explains the photoelectric effect because regardless of the amount of photons, if the individual photons don't have enough energy to knock electrons off atoms, they're not going to generate a current. Whereas regardless of how few photons there are, if they have enough energy or a high enough frequency to knock an electron off an atom, they will generate currents. As photons are seen as discrete, quantized packets of energy of light, that gave birth to a field of study known as quantum mechanics. Quantum coming from quantized. This has been day 3 of my fundamental experiment in physics series, so please make sure you're liking and following so that you don't miss any more. Thank you for doing all of the stuff you normally do here. And until next time, I've been Dr. Alex Foden, the Science Wrangler, and I shall see you one of these days.